So the third category of terminal operation we're going to talk about here is reduce. And this is a very interesting terminal operation. You'll see it has some powerful and yet subtle semantics in some cases. And we're going to demonstrate that again with yet another variant of our Hamlet program to illustrate how it works. The difference between collect and reduce is that collect returns a collection. Surprise, surprise. But reduce returns a single primitive value, like an int, or a long, or a double, or something like that. And so you can kind of think of it as, sort of merging all the values in the stream in reducing it to a single primitive result. Okay, so let's take a look and see how this might work. So let's assume for sake of argument that we have created a map that maps Hamlet character names to their lengths. So that's what we kind of did before. So we already did that. And now we've got this map. We call it matching characters map. So what we're going to do now is we're going to talk about how to take the values portion of the matching characters map, which is a list of longs, and we're going to turn it into a stream of longs, which is what we show here. So values is a factor method that returns a list of the values. We turn that into a stream, and now we're going to go ahead and reduce stuff to come up with a sum of the length of all the characters' names in the play Hamlet. So we're going to end up with, it should probably really be sum, but we're going to take all the lengths and add them up. So it's a sum of those results. Now, reduce is kind of an interesting method. It has several parameters, and there's a couple different variants of reduce. The first variant here is one where we're going to give it what's called the identity value. And this is used for two things. First, it's used as the initial value of the reduction. So for sum, we want to start with 0 for reasons that'll become clear. And it's also going to end up being the default result if there are no elements in the stream. So if we ended up with no matches at all, like let's say we looked up the name, I don't know, Judy Garland, that wouldn't be found in Hamlet probably. So we'd end up with a stream that had no elements in it. In that case, when we reduce it, it'll come back to 0, which is the initial value here. This is also something that's called the identity value. And we'll talk more about that later, but in a nutshell, identity in arithmetic operations is, value plus identity equals value, or value times identity equals value. So for addition, identity is 0. For multiplication, identity is 1. So keep that in the back of your head. So we're going to kind of initialize things to 0, and then we're going to go ahead and sum stuff up. Sum is a method reference, which plays the role of something called an accumulator, which, as you can see in this case, is a stateless function that takes two parameters and merges them into a single so-called reduced value. And that reduced value needs to be immutable. And what that means is that once it's set, it shouldn't change. And we'll talk about that in a minute because it's kind of subtle. So immutable means can't be changed once the constructor, or once it's created. Once sum creates a value, that value can't change. If you don't want to use a method reference, you could always use a lambda expression. So this sum method reference really is the same as, x comma y, arrow x plus y. So those have the same meaning. They'll probably perform the same in terms of computation. Maybe this would be a little scotch faster if it was inlined or whatever, but it should be about the same. There's also a 3-parameter version of reduce. So the one we just looked at was a 2-parameter version. And the 3-parameter version of reduce can be used with parallel streams in order to be able to do a map reduce style computation. So what happens in this particular case, and you can read more about this or you can watch a video that talks about this. You can talk about this video talks about, among other things, the 3-parameter version of reduce. So what we do here is we take our list of characters in Hamlet, we convert the list into a parallel stream, which, by the way, is probably overkill because we're only going to have a handful of Hamlet characters, but let's assume that Hamlet had thousands. It was like Game of Thrones. There were thousands of characters in Hamlet that were killed off every scene. They'd kill off everybody from the previous scene. Then it would be more like Game of Thrones. So we have a parallel stream, and we call the 3-parameter version of reduce, starting out with 0 because we're still adding things. And the first parameter is called an accumulator. And what this is going to do is it's going to take the element in the stream, and we're going to add it to the current sum. So we're going to have a running sum. So this will basically sum things up. So you have sum, comma, s for current element in the stream, which is string. And we say sum plus s plus length. That becomes the new sum. And that's what's called the map operation. And that's going to get applied in different threads on the stream that's broken up. And I'll talk more about how that would work in a second. And then we have what's called the reduce operation, which will sum up all the partial elements that are created by having sums added up in different threads. So we'll talk more about how this works later. But this in some cases can be an improvement if you're running with parallel streams. Here's yet another example. This is yet another example. This is a shorthand or syntactic sugar that avoids the need to use reduce by using a helper method called sum. So you can see there's no use of reduce here, but sum is also a terminal operation. And this will show off something else cool that relates quite specifically to your programming assignment. So I want to make sure we talk about that here. So as you can see, we have our values list, which we turn into a stream, same as before. And now we introduce a new method, a new aggregate operation, which I should have actually talked about when we talked about map earlier, because it's important to understand this. What map to long does is it takes some behavior and it's going to map the results from a stream of objects to a stream of longs. And that's really important, and you'll see why in a second. So map to long is going to take this stream of longs, where these longs are reference types. And it's going to convert them from reference types into primitive types. That's what long value is going to do here. So long value is a method reference that's basically a converter, and it goes ahead and converts the long reference into a long primitive. Remember, Java distinguishes between reference types and primitive types, but it's got these sort of boxed operations for reference versions of primitives. There's a long discussion of that beyond the scope of this class. And so as a result, we want to end up with a stream of primitive longs, and then we can sum those together to get the count or the sum of the name length. So we can sum the stream of long primitives into a single reduced result. Now, this is important for your assignment 2A because one of the operations, I forget which one is crawl URL or crawl something or other, needs to return a sum of something. And there's various ways to do that, of course, but one of the most satisfying ways to do it is to use map to long, and we'll talk about what will go in the conditional, or we'll talk about what goes inside this behavior part in a second. You use map to long, or in your case I think it's map to int. You would map to a primitive type, int, and then you would go ahead and sum the result. So you can use map to int, map to long, I forget which one, I think it's map to int. And then you would end up calling sum. And sum only works if you've got a stream of primitives, because if you look carefully, you can see that the sum method comes out of long stream, which is this kind of specialization of stream for the primitive type long. There's also an int stream, int stream. So if you're trying to write your program for assignment 2 and you're getting these weird compile errors and it's yelling at you, it's probably because you're using map here as opposed to using map to int. Now, again, you don't have to use map to int followed by sum. You can do map, and then you can do like a reduce operation to do the same thing. So you don't have to do map to int, but if you're getting a weird error, that's why. Now, keeping on the assignment 2A description for just a second, some people are trying to write that method by having two streams and using filter. And I think you can do it that way, but maybe a more concise way to do it is to have a single stream And instead of using filter, use the famous question mark colon operation, which is often called the ternary operator. So if you're trying to figure out what I'm talking about, Google ternary, as in three parameters, ternary operator Java, and it'll show you question mark colon. And question mark colon is a way of being able to have conditional behavior in a context that expects an expression rather than a statement. So a statement would be like, if some condition, do this, else do that. Whereas question mark colon lets you do conditional processing, but in an expression context. So what you could do here in your thing is you'd end up getting in an entry, or I think it's a page element. You get an element, you could say element equal, you know, E equal, wait, what is it? You want to see whether or not what the element is. E dot get type, open close paren, equal image, question mark. Then you do one set of calls, colon, you do the other set, in which case it'll be a link. So I think it's link and image are the two options. So you can do that all in a single stream with a conditional expression. So that should make your code a little bit more concise. Any questions about that? So that'll help make your assignment 2A a little simpler. And I should have talked about that when I talked about map earlier, but this discussion of map to long introduces the same thing. There is yet another way you can collect the results together to create a primitive value, just to be even more, you know, endlessly, too many variables, too many variations for our own good. Instead of using reduce, or using sum, you can go back to our good friend collect, and you can pass in a collector, which is called a summing long collector. And summing long will take the stream of values, and in this case, we would have a stream of reference objects of type long, and then we would use the summing long collector to collect them into a single reduced primitive long. And so collect will trigger the stream processing, and then summing long is a factory method that returns a collector that, when run, will end up summing up all the results, converting them into primitive values, and what we'll end up with is a sum, a single result at the end. So that's yet another way to do it, just to be even more diverse in terms of our processing of all this stuff. So that's the end of the discussion of the reduce terminal operation. We'll see that there's more subtlety to it than may have been apparent in my discussion here in the next video, but I just wanted to make sure that people are familiar with the three common variants. There's for each and for each ordered, there's collect, and there's reduce. And sometimes they're interchangeable, sometimes they're not, depending on what you're trying to do. Like I said, collect is probably the more common one for most programs, but reduce operations and reduce style terminal operations are very useful too. There are also other terminal operations. So we had things like, you know, find first, find any, none match, all match, any match, all the stuff that we talked about before briefly when we talked about short circuit operations. Those are also terminal operations as well. And they're a bit more specialized, so I'm not talking about them in this context.